In this video, we will be looking at one method of solving quadratic equations. So first of all, a quadratic equation has a degree of 2, meaning the highest exponent is 2. So for example, 2x squared minus 10 equals 12 is a quadratic equation. In grade 9, all you did was linear equation. So you had something like x minus 10 equals 12, for example. But the minute you see that exponent of 2, like in these two examples, you have a quadratic equation. Now, there are 3 different methods for solving quadratic equations. There is a method called isolating, factoring, and quadratic formula. Today, we will be looking at isolation. Now, for you to solve by isolation, your quadratic equation has to be in a specific form. And that form is that there is only a single x squared term in your equation. So for example, if you look at A, B, C, and D, you will notice that there's an x squared term in your equation, but there is no other variable. There's no other x to be found. It's just the x squared. The other scenario is when you have your x contained inside a bracket to the power of 2. And again, no other x to be found. So for example, if you look at E and F, you have the bracket to the power of 2, and the x is only inside the bracket. Now the reason we can isolate is because x is only found in one place. And the way we're going to isolate is in a similar manner like you did in grade 9 with linear equations. So we're going to isolate for that x squared or that bracket using opposite operations. And then we might do some dividing, and we're going to do some square rooting because of that exponent of 2. So let's take a look at our first example. We have 3x squared minus 75 equals 0. Your goal is to isolate for x squared. Our ultimate goal is to isolate for x, but for now, let's just say x squared. We know in grade 9, you would always get rid of the constant first and bring it to the other side. So when we bring the 75 over, it becomes positive. We also know that when there's a coefficient in front of our variable, we can get rid of it by dividing both sides by that number. So we get x squared equals 25. And here you are almost there. We know x squared equals 25. We have to think about the opposite operation of an exponent of 2. And the opposite operation is to square root. So we square root both sides, and x is equal to plus or minus 5. Now the reason it's plus or minus is because when you square root a number, you are asking yourself or the calculator, what to the power of 2 gives you 25? 5 to the power of 2 is 25, but negative 5 all to the power of 2 is also 25 because a negative number times a negative number is positive. You have to present both options or you are missing half of your solution. So this is our answer. Let's try it again. Negative 2x squared plus 4 equals negative 28. Let's bring the 4 to the other side because the constant always moves over first. And when it moves over, it becomes negative. Negative 28 minus 4 is negative 32. We also know that next we have to get rid of that coefficient using division. So we end up with x squared equals 16, which is good. I was getting a little worried that we had a negative number because I know you can't square root a negative number, but now it's turned positive. And your final step is always to square root both sides. That way, the exponent of 2 gets canceled out and we just have x, and then the square root of 16 plus or minus 4. All right, the next one. We have a fraction there. It's okay. We're going to bring the negative 1 over like the other scenarios. It's going to turn into plus 1. So that's a 9. And now you can divide both sides by a quarter, or you can multiply both sides by the reciprocal. The reason is, when you divide by a fraction, so just a little side note here, if you did 9 divided by a quarter, we know that the division of fraction is the same as the multiplication of the reciprocal. So instead of going through the steps, you can always just multiply by the reciprocal right away. So here's how I'm going to show it. I'm going to multiply both sides by 4, which is 4 over 1. And that way 4 times a quarter is just 1, so we're left with x squared. And 9 times 4 is 36. But you can also show it as division if that makes you happier. And then the square root of 36 is plus or minus 6. All right, I want you to try D on your own and then come back to check your work. So we should first bring the 10 over. So you're left with negative 3x squared equals negative 5 minus 10 to get negative 15. Then we'll divide both sides by negative 3. And actually something a little weird happens. When we divide, we get 5. 5 is not a perfect square. So I can square root both sides, and I can present my answer in two different ways. I can do an exact form and say, you know what, x is equal to plus or minus whatever the square root of 5 is. Or if I wanted it to be rounded, I'd put my squiggly signs and I would take the square root of 5 and just round to 1 decimal. So approximately plus or minus 2.2. So you might not always get a nice whole number, and that's okay. We can get decimals as well. All right, so in all 4 of these examples, we just had that nice x squared term, okay? And the fact that there was no other x around told us we should isolate. In the next few examples, we have our bracket to the power of 2. So, just like in the first 4 examples, instead of isolating for x squared, we're going to isolate for the bracket squared first. We are going to have a few extra steps afterwards, but we're going to follow the same idea of move the constant over, divide out the coefficient. But this time we're dividing the coefficient of the entire bracket. One thing I want you to never do is try to get rid of the brackets by doing some distribution. First of all, some people might be tempted to just bring the exponent in and say x squared plus 1 squared, which is completely wrong. Some people might do FOIL, so write the bracket out twice and do distribution that way, which would be correct, but you're actually just putting more work for yourself when this can be done in a quite efficient manner. So let's check it out. So first thing, just like the previous examples, and just like grade 9, we're going to bring the constant to the other side and turn it positive. Now there is no coefficient in front of the bracket, so we're going to jump straight to, I need to get rid of the exponent. Another quick little note, you cannot touch anything that is inside of the bracket. Right now it is trapped by that exponent of 2. That 2 is like a jail cell. Nothing can be removed until the exponent is removed. So we're going to square root both sides. And when we do that, we end up with x minus 6 equals square root of 49 is plus or minus 7. Now, this doesn't look the nicest. So instead of writing it like this, I'm going to write 2 separate equations. X minus 6 equals the positive 7, and x minus 6 equals the negative 7. So now I just have 2 little linear equations to solve by bringing over the 6. So 7 plus 6, which is 13 for one of my answers, and negative 7 plus 6, which is negative 1 for the other answer. So I still get 2 answers, but they're not the same. But I still had the plus minus the minute I took the square root. Let's try it again. I'm going to bring the 7 over because that's the constant. When I bring it over, it becomes negative. And 407 minus 7 is 400. Now in the previous example, we had no coefficient in front of the bracket. Now we do. We divide it out. And again, we cannot bring the 4 into the bracket. What is inside is trapped. Nothing can be removed and nothing can go in. So we're left with x plus 1 all squared equals 100. Now we're left with our bracket to the power of 2. Now we can actually square root both sides. And I'm just going to write my 2 equations right away. X plus 1 equals, the square root of 100 is 10, or x plus 1 equals negative 10. I'm writing both versions. Now I'm going to bring the 1 over. I'm not going to show my steps here, but I would do 10 minus 1, which is 9. And for the next one, negative 10 minus 1 when I bring it over to get negative 11. And there are our two answers. All right, I want you to try G on your own. Just remember that there is a negative 1 here in front of your bracket. Try it, pause the video, then come back to check your work. So you should be bringing the 10 to the other side. And you would have 1 subtract 10, which is negative 9. The negative is concerning. However, you're going to divide both sides by negative 1. And that fixes our problem because now it turns positive. I've isolated from my bracket, so I'll square root both sides. The square root of 9 is 3, but it's also negative 3. You need to present the two options or half of your answer is missing. When we bring the 5 over, for the first one, you're going to have 3 minus 5, which is negative 2. For the second one, you're going to have negative 3 minus 5, which is negative 8. So please note when you do have a bracket to the power of 2, your answers will not be identical plus or minus. You have to, isolate for your variable in each sub-equation to get the two different answers. All right, last one. We're going to start off by bringing the constant over. 29 plus 3 is 32. If you want to show your work of bringing the negative 3 over and turning it positive, you're more than welcome to. Now, to get rid of the 1/2, you can either show that you're dividing both sides by a half, or the way I like to show it because it just looks a little cleaner, instead of dividing by the fraction, I'm going to multiply by the reciprocal, which is just 2 over 1, but I'm going to write it as 2. And whatever you do to one side, you do to the other. That way, 2 times a half is just 1. So we're left with our nice bracket, the power of 2. And 32 times 2 is 64. Now we're back to square root both sides. The square root of 64 is 8 or negative 8. Don't forget the other half, plus or minus, every time you square root. Now when you bring the negative 7 over, you're going to have 8 plus 7, which is 15. When you bring it over in the other scenario, you're going to have negative 8 plus 7, which is negative 1. And there it is. That is how you solve a quadratic equation by isolation. But again, you can only use this method when your equation has a single x squared with no x. So if you have x squared minus 5 equals 10, you can do isolation. If you have x squared minus 5x equals 10, no isolation because of that x. Okay? Or you have a bracket to the power of 2. So for example, if I have x plus 2 squared minus 1 equals 8, this is okay. If, however, there is other stuff outside the bracket, so I put another variable in there, not good. Okay, your x has to be contained in a single place, just the x squared or just the bracket in order for isolation to work. And then after that, to isolate, it's your grade 9 skills. Bring the constant over, divide out the coefficient, and then you'll have a little bit of square rooting as well. And please don't forget the plus minus in your answer. And that's it for solving by isolation.